This is lesson 26, which is VHDL example 13. And in this example, we'll design the same 7-segment decoder we did in the last lesson, except in this case we'll use a case statement. Here's the truth table that we derived for the 7-segment decoder, hex 7 seg. And remember, in the last lesson we made Carnot maps for each of these A, B, C, D, E, F, G. Now that was sort of complicated and a mess, and I've told you that normally we don't write logic equations in VHDL to solve logic equations. What we do is we write the behavior, and the case statement is an easy way to describe the behavior of this truth table. We can basically just write the truth table in a big case statement. So let's see how we'll do it. Here's the same entity we had before. X is the 4-bit input. A to G is the 6-bit output. And in the architecture, we'll just write this big case statement. So it'll be in a process. You remember, case statements have to be in a process. So process X, that's the 4-bit input. Case X is, well, when X is 0, 0, 0, 0, that is, we want to draw a 0, we'll just turn off G. So this is the bit pattern for A, B, C, D, E, F, G, straight from the truth table. When 1, 2, 3, all the way up to F. Well, instead of putting F, we just put when others. Remember, case statements have to include a when others, so we just use that to take the case of F. So here's 8, where we turn all the segments off, you see. So this is very easy, much easier to make a case statement than to derive all of the Carnot maps that we did in the last lesson. So this is normally the way we'll do it. Now, there's an alternate way. You remember in the previous one, let's go back and look, here we wrote X as 0, 0, 0, 0 as the string, the 4-bit string. We actually wrote out the 4 bits, double quote 0, 0, 1, 0. We could also do it a different way. Here's the same entity, but now we can just write the hex values 0 to F, or E in this case, plus others. And the way you write hex values in VHDL is with this capital X. So X double quote 2 would be hex 2. X double quote 9 is hex 9. X double quote E is the hex E. These are all the same, so this is just another way of writing the case statement for a 7-segment decoder. Now let's try this out. I'll have you download this to the board and let's see if it works. So we'll use the 4 rightmost switches for X. So we're going to use these 4 switches where you can set 0 to F. We want to see if we get 0 to F showing up on the 7-segment display. Well, the question is, which 7-segment displays are going to show up on? Well, it turns out that this A to G is in the UCF file. So these are the A, B, C, D, E, F, G. But the A through G is the same for all of these 4 segments. That is, they're all wired together. So when you turn on A, you'd turn on the A in principle for all 4. However, you can select which segment you want to display. There's another input, AN, which enables a particular segment. And you enable it by bringing AN to 0. So AN 3 down to 0 will enable segments 3, 2, 1, and 0 by bringing them to 0. If the corresponding AN is a 1, then it will disable it, and that won't be that 7-segment display won't be displayed. There's also an input called DP for decimal point. So to turn on the decimal point, you make DP 0, and to turn it off, you'd make it a 1. So to try it, let's run this program then. Here's the component for hex 7 seg with the X input and A to G output. We'll set AN to all 0, 0, 0, 0, 0. This means we'll turn on all digits. We'll turn off the decimal point by making DP1. And then we'll just port map hex 7 seg. So the X in hex 7 seg will connect to the switches, 3 down to 0, remember, and the A to G, this A to G, will connect to the output A to G of our top-level design. So if you compile this program and run it, then when you change the 4 switches from 0 to F, you should display 0 to F on all 4 segments. Now you might wonder how you can turn off segments. Well, I've told you, you could play around with this AN, make some of these 1, and you'll turn off those segments, and the rest of the segments will display whatever the switches are set to. Now you might wonder how you could display different digits on the 4 segments. Suppose you wanted to display 1, 2, 3, 4, for example. Well, we'll answer that question in the next lesson.